Hello and welcome to another GCSE revision video, and in this video, part 5 of my videos on circles, we're going to look at the circle theorem that talks about perpendicular chord bisectors. Basically, the theorem says that if you take a perpendicular line from the centre of a circle to a chord, then that perpendicular line will always bisect the chord. That is to say, it is a perpendicular bisector. Let's try and prove that by drawing two straight lines from the centre of the circle to the ends of the chord. And we all know what those two straight lines are. Since by definition a chord touches the circumference of a circle at 2 points, the lines from the centre of the circle to the edges of the chord must be the radii of the circle. Now if we label the centre of the circle C for centre, and we use the letters A and B to label the edges of the chord, then we can construct a triangle ABC. And we know that triangle ABC must be isosceles from the circle theorem that we discussed in part 4 and which we proved in part 4. Now, by definition, the perpendicular line from point C to the chord makes two right angles. This is because the word perpendicular means it touches the line at 90 degrees. That the perpendicular means 90 degrees, and 90 degrees is a right angle. So by definition, our line from the centre, the perpendicular line to the chord, is at 90 degrees to the chord. Now if we label the point where the perpendicular line touches the chord M for midpoint, then the triangle AMC and triangle BMC both share the same line, and that line is the perpendicular line. And both of those right angled triangles BMC and AMC have the same length of hypotenuse, which is the radius of the circle. Now, since they both have the same radius and they both share the same length MC, and they are both right-angled triangles, then by right-angle hypotenuse side proof of congruence, triangle AMC must be congruent to triangle BMC. That basically means that the two right-angled triangles are exactly the same. It means that all three lengths must be exactly the same and all three angles must be exactly the same. So length AM must be the same as length BM, and therefore length CM must bisect length AB. The word bisect means to cut exactly in half. So length AM and length MB are both exactly the same length and both cut length AB exactly in half, which is exactly what we set out to prove, that a perpendicular line from the centre of a circle to a chord will always bisect the chord. Okay, I hope you found that video helpful. If you did, don't forget to like, comment and subscribe. If you're taking your exams this year, I'd like to wish you all the best with your revision and all the best with your exams. And I look forward to seeing you in a future video.